Okay, so significance testing, you know what? I'm feeling a little lazy today.
Yay. Can we make waffles? Can we? I like
Oh, boy. Okay,
Yeah.
so instead of doing 10.1-1 and 10.2-1 today, we're just gonna do 10.1-1 and call it, 1-3. We'll call it good today, right?
Thank you.
All right, so.
Did you guys get to the copy? Or did you actually learn stuff? No, what? So that's why.
So this will be part 3. Okay, so comparing two proportions. So we talked about comparing two proportions. If you had a population, you had two different populations, large N2, large N1. We do an SRS. And we do an SRS of N1, and we do another SRS here of N2. In other words, you don't have to do the same number, right? The survey size can be different between the two. And since we're talking about this, we get this, P1, P2. We're going to P1 hat, P2 hat. And this was sigma 1, this was sigma 2. So our sigma P hat 1 was equal to what? This would be, whoops, P1 hat 1 minus P1 hat over
And
small n1, right? And then we would do P2 hat, and I would get P2 hat 1 minus P2 hat over n2. But before this, we had to check the 3 conditions, right? The 3 conditions for each one. Okay, you just can't do one of them. You have to do both of them. So you have to make sure they're both in SRS. You have to make sure that both N1 and N2 are not oversampling. You can't sample more than 10%, all right? And also the large counts. For this guy and this guy, NP1 and 1 minus P1 has to be greater than 10. NP2 and N1 minus P2 has to be greater than 10, correct? So that's in a nutshell what we did, right? And then we talked about the confidence intervals, right? We constructed confidence intervals. We did a confidence interval, right? And we said the confidence interval was what? The confidence interval for P1 minus P2 was plus or minus Z star. And then we had 1 minus PP hat 1 and 1 plus P2, 1 minus P2, right? This is what we did.
Fun.
Okay, so this is in a nutshell what we did. So we did this guy, the first for 10.1-1. This was 10.1-2. Okay, so what do you think? So now we're going to talk about significance testing, right? Significant testing, okay? Significant testing is what? We're going to test for P1 minus P2, right? We're going to test something about this, right? Whether it's going to be equal to 0 or greater than 0.2 or whatever it may be, right? We're going to test something. We're going to do significance testing here, right? So if you think about our proportions back when we had single proportions, remember the confidence interval and the significance testing, the prerequisites were the same, right? It's still the SRS, less than 10%, and the large counts, right? Same thing. So even when we're doing 2, what do you expect it to be if we're doing the significant testing? Wouldn't you expect it to be the same? And it is, okay, it is. So if you go to page 630, bottom, there's a green box. There's a green box there, okay? So you can read that. If you look at that, it's the conditions. And the conditions are actually exactly the same. Let's go to the example, hungry children. Let's pick on cat. Go ahead and read that example for us.
Researchers designed a study to compare the proportion of children who come to school without eating breakfast in two low-income elementary schools. An SRS of 80 students from school 1 found that 19 missed breakfast today. At school 2, an SRS of 150 students included 26 who missed breakfast today. More than 1,500 students attend each school. Do these data give convincing evidence of a difference in the population proportions at the sigma equals 5% significance level?
Okay, all right, so significance of alpha of 0.5. So we have to check the conditions, right? So we're trying to check the conditions. So N1 was what? What was N1? 80. What was P hat 1?
19.
19 over 80, right? 19. It's a proportion, right? So 19 over that. So what was N2?
150.
150. And this guy was what?
26 over 150.
Okay, all right. So you guys should be used to this by now, but what is NP? 19, right? N1 minus P is what? It's 80 minus 19, right? 61, right? Okay, so they're both greater than 10. Your NP is 26 here, right? Right? You guys have done this enough, so you guys should be familiar. You understand what I'm saying, right? Because you get what? NP is basically N and then whatever X you get over P, over N, right? That's the proportion. So these guys cancel out is what I'm saying. So your NP is gonna be 19. Okay, so you get 19, and then 1 minus that is the leftover. So it's 61. Okay, so over here it was 26. The leftover was 124, right? So the large counts all work for both of them. They were large schools, so this is less than 10%. They were both random samples, right? Okay, so we're good with that. So that was A. No, that was B, I guess. A, state the appropriate hypotheses. So we are saying that they are different or not, correct? Is that what we're looking for? So your whole is going to be there the same. So your whole would be that P1 is equal to P2, or P1 minus P2 is equal to 0. Same thing, right? Okay, the ha would be what? The ha would be P1 minus P2 is not, alarm bells should be coming. What does this mean? It's two-sided. It's two-sided. So when you find your p-value, you would find it the normal way you find it, and then you got to multiply it by 2, right? To find the actual p-value, right? To find the actual p-value, right? Okay, so let's go ahead and flip the page. If you flip the page, now it tells you to actually do it. Does it say? Calculate the standard variance test statistic and the p-value. Okay, so let's go ahead and do it. So if we do it, what do we get? So alpha at 0.05, right? Alpha equal 0.05. P1 was this guy. P2 is this guy. Okay, so what do we need to do here? We have to find out what P1 minus P2 is, right, first? So it's this guy minus this guy, right? And if we do that, what do we get? We get 0.0642. 0.0642. That's a test statistic, right? And then C, what conclusion would you make using that? So if you go ahead and find, so what do we get? Okay, so this is interesting. So look at B, look at the solutions there, okay? You adding them together, right? You're gonna add them together. So you get an aggregate of, you add them together. So you add the 19 and the 26 and then the 80 and the 150 together because that is your, if you look in that two-way table, that's what you get. See the two-way table there? In the middle, because you're gonna have a total of 230. You get 45 of them are gonna have no breakfast kids, right? So it's 0.196, okay? And the Z was this guy, right? Because if you have the total mean was what? I'm gonna have to erase this. I didn't want to erase it, but I guess I will. Leave that. Okay, so we're gonna have 45 over 230, right? That is the mean. Okay, so that is going to be your mean like this. And that was, what was that value? That was 0.196, that was 0.196. So this would be, right here would be what? Would be 0, right? If they were the same, if P1 and P2 were the same, right? Because that's the whole that we're looking at, right? The whole that we're looking at. Okay, and this here, 0.0642, right, would be where we're at right now. That's what P1 minus P2 was for our sample, right? So we're here, and then we're going to do what? You have to find the Z-score, right? You have to find the Z-score, right? You have to find the Z-score. So I want to find the Z-score from here to here. So it's going to be 0.0642 minus 0 divided by the standard deviation. The standard deviation is going to be, P1 was what? What is 19 divided by 80 was 0.0237, 0.0235. So 1 minus that's going to be 0.7625 divided by 80, right? Hang on a second. Okay, so the 0.2375 minus 0.1733 is this guy here, right? Right, so I'm subtracting that from 0. Now the difference here is the 0.196. That is the combined P. So they're using the combined P. Okay, so they're using the combined P. If you go right on top, right above the example, so it's 0.1. So this actually is 0.196 times 0.804, I guess. Is that correct?
Yeah.
Over not this. What is my n here?
80.
80. And then what do we have? And you have 150, right? 0.196, 0.804. Okay. And if you look up there, if you look right above, right above there. In other words, P hat gives the overall proportion of success in the combined. In other words, use P hat in place of both P1 and P2 in the denominator. That's what you're going to use. That tells you to use that. Okay. So blah 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 blah. We did that. If we do that, we get what? 1.17 1.17? 1.17, so what does that mean? So from 0, from here to here, my z-score is 1.17,
So let me do like
okay? So what do I need to do now?
norm CDF,
I have to do a norm CDF. I do a norm CDF, what do I get?
a number.
So I get a norm norm CDF from here to over here, right? 0.0642 to, I don't know, 100. And then I would go 0 and what's my standard deviation? Is it? Norm CDF. Yes, it is 1. Oh, wait, no. Okay, I'm doing this. That's a standardized version. I'm not doing the standardized version here. So 0, 0. It would be this guy, but I don't know what that guy is because I didn't do the calculations. Oh, and it's 0.055. 0.055. Okay. Somebody put that in the calculator. Do that please for me, please.
Okay, that's the not standardized.
This is a not standardized version.
So why do they bother?
I should be getting 0.121. Did everybody get that? Right.
I'm just confused, why we're doing different than the book does.
I mean, I could do the book if I want. This is not the standardized version here.
Okay.
Okay, if you're doing the standardized version, then you would use what? Then you would use this guy that we found.
But why did they bother standardizing it?
I don't know. That's what I'm hoping this would come out the same. It should come out the same. No?
I'm doing it.
Are you doing it right now?
What did you say you get?
0.1210. Okay. So same thing, 0.1210. Okay, so this guy is 0.1210. So I have to multiply that by 2, right? But it's two-sided. So if I multiply this by 2, I'm going to get 0.242. That's not 242. I'm thinking something and writing something different. 0.242. So my p-value is it bad? It is greater than your alpha, which was 0.05.
We reject.
So we failed to reject. We failed to reject, and there is not convincing evidence for this. Okay, there's not convincing evidence for this. Okay, so we cannot reject this. Okay? In other words, the difference isn't large enough. Right? Okay, so now obviously there's a way to do this in your calculator, and that's in your technology quarter on page 633. Page 633, it's the two-prop z-test, two-proportion z-test, okay? If you just kind of look at the, there it says x1, n1, x2, n2, right? And then it's not equal to here, right? And then you just go ahead and, if you do that, and it pops right out, it gives you the z-score, and it gives you the p-value,
It gives you the mean.
all the good stuff. Okay, so. So, okay, so we're good with that? So that's how you would do that. Let's go ahead and, so there is a putting it all together, which is another one more example of that. And that's going to be the last. So I'm going to hold off on that. We'll do that second half. So let's go ahead and start working on some of the homework.